Never-changing laws govern an ever-changing universe. Observing them, defining them, recording them, and applying them gives us science and technology. Science decodes for us the language in which universe is written and read. It is the language that truth speaks. A tiny minority from among us comes gifted with a passion to decipher the language of the universe. We call them scientists. They enjoy unraveling the mystery behind everything we experience in and around us and beyond and beneath us. They devote their lives to the pursuit of the physics and chemistry of existence and the math and measure they come clad in. We owe them, one, for demystifying the truth of life on earth to us, for making the journey of life more interesting, more meaningful, and more efficient than it would otherwise have been. Miss Anna Modayil Mani, fondly called Miss Mani, holds an illustrious place among the outstanding scientists of modern India. Esteemed among the top 5 women scientists of independent India, like Janki Ammal, Kamla Sohoni, Ashima Chatterjee, Rajeshwari Chatterjee. The first woman scientist from her home state, Kerala. How does she make a difference to our lives? What is she remembered for? What kind of a person was she? How did she get where she did? Why do we owe her one? Miss Anna Modayil Mani was an agnostic born in an aristocratic Christian family. To an agnostic father, a prominent civil engineer in Perumedu, a beautiful hill station of the princely state of Travancore on 23rd August 1918. It was later to be the largest chunk of the state of Kerala. Can one be separated from one's character? People play a role in shaping one's character. Things play a role. Anna's achievements as a meteorologist cannot be separated from her character either. The influences people and things played in shaping her character cannot be separated from what she grew up to achieve either. Her father and family background played a prominent role in instilling a scientific and rational temperament in her. Her love for nature played a role too. Young Anna was a voracious reader. At the age of 8, she read all the books in Malayalam available in the local library at the time. And by 12, all the English books too. Clearly, she was consumed by the lust for knowledge and quest for truth from quite an early age. In fact, on her 8th birthday, something interesting happened. According to her family tradition, she was gifted a diamond earring on her birthday. Anna declined that gift. She asked her father to gift her with an Encyclopedia Britannica instead. She was fond of physics. When she joined Madras Presidency College for graduation in physics, she was the only girl in a class of 6 students. In 1939, she passed out with honors in physics and chemistry from Madras Presidency College. Her passion for physics, lab, and experiments was insatiable. After graduation, she joined Women's Christian College of Madras as a physics demonstrator. It was here that a colleague advised her to apply for her postgraduate studies in Indian Institute of Science, Bangalore. Predisposed to science and technology ever since the British made it one of their favorite strategic settlements in the south. 1940, Anna joined Indian Institute of Science in Bangalore on a scholarship. And the head of physics department? None other than Nobel laureate Professor C.V. Raman. Her life was to take a new turn here. It was an exciting time of research at Raman's lab in Bangalore. It was later to be the renowned Raman Research Institute that Professor Raman founded in 1948. Professor C.V. Raman offered her the opportunity to join him on his continuing research on fluorescence. Fluorescence is the emission of light by a substance that has absorbed light or other electromagnetic radiation. An unthinkable privilege for a woman at the time. Anna worked here on spectroscopy of diamonds and rubies. She recorded and analyzed fluorescence, absorption, and Raman spectra of over 30 different diamonds. Fluorescence spectroscopy is a type of electromagnetic spectroscopy which analyzes fluorescence from a sample. It involves using a beam of light, usually ultraviolet light, that excites the electrons in molecules of certain compounds and causes them to emit light. Between 1942 and 1945, she published 5 papers on luminescence of diamonds and rubies. She submitted her PhD thesis to Madras University in August 1945. But Madras University did not accord Anna Mani the PhD that she so much deserved. The university argued it cannot grant her a PhD as she did not yet have a master's degree. Her dissertation still remains in the Raman Research Institute library. September 2, 1945. Second World War had just ended. India was on the threshold of independence. The British government was offering scholarships to eligible Indian students to study in the UK and USA. Anna was qualified for it too. However, one of her Raman Research Institute colleagues persuaded her to avail of the scholarship. He reasoned that British government was offering India's own money as scholarships to Indian students. Anna saw his point and decided to avail of the scholarship for higher studies in the UK. But there were no scholarships offered for physics, her chosen subject. Instead, it was offered for meteorological instrumentation, as there was a great need for expertise in this line at the time. Meteorological instrumentation equally fascinated Anna. She now headed to London in a troop ship with many other Indian scholarship students. She spent a year at Meteorological Office Instrumentation Division at Harrow. There she mastered the mechanics of upper air instrumentation. She spent time at the National Physical Laboratory at Teddington, Learning about standards and standardization of weather instruments, Anna impressed both faculty and fellow students at Harrow with her skills at conducting experiments. 1948. Anna returned to India. India Meteorological Department in Pune was waiting for its historic journey with Miss Anna Mani. It was a time when all meteorological instruments were imported from Europe. Anna was resolved to design and manufacture Met instruments for India in India itself. Her first challenge was to construct a range of instruments including rain gauge, thermographs, barometers, and anemometers. It wasn't an easy task though, because there hardly was any technically skilled manpower in India at the time. Rain gauge is a meteorological instrument for determining the depth of precipitation that occurs over a unit area and thus measuring rainfall amount. Thermograph. Thermograph makes use of the physical property of a bimetallic element which shows characteristic changes with change in temperature. Hygrograph, an instrument for recording automatically variations in atmospheric humidity. An anemometer is an instrument that measures wind speed and wind pressure. On a war footing, Anna trained and equipped a core group of experts that could design, manufacture, calibrate, install, and operate weather instruments at IMD. This period is considered one of the most exciting times of activity in the annals of India Meteorological Department's Instrumentation Division. The department was a hive that hummed with activity around Anna, the Queen Bee. Her colleagues proudly reminisce the golden days of instrumentation that Miss Anna Mani brought into India Meteorological Department.
For the first time when I met, I had not even heard of her, though I am born and brought up at a place 5 kilometers away from the place where she was born and brought up. What impressed me for the first time was the way in which she conducted herself. She was an excellent taskmaster. She will assign work to us and ask us to complete in 3 days or 4 days. In the natural course of our working hours, it would have taken 10 to 15 days. But she was not concerned about that, always result oriented, dedicated to science, accuracy and perfection. She went on developing instruments, modifying it, incorporating the latest technologies. She was always on the lookout for the best performing meteorological instruments. She traveled widely all over the world.
1953, Anna was promoted to head the instrumentation department of over 121 men, an unusual achievement for a woman at the time. 1960, thanks to Miss Anna Mani's dynamic leadership, hard work and indomitable determination, IMD now had a self-reliant instruments division. India didn't have to import weather instruments anymore. The foundation she laid continues to keep India's meteorological instruments division going strong.
She has done a tremendous work in this office. You call it as a workshop unit, you name it as a radiation unit, and all this development she was responsible. She is responsible for basically making all surface meteorological instruments related to the surface observatories. There are 539 observatories still we are maintaining in our office as on date, and plus there are other observatories, application observatories like floodmet offices, hydromet divisions, agromet, another 500 stations. So almost 1000 station surface observatory network we are maintaining.
In 1960, Anna also turned her attention to the measurement of ozone in atmosphere. World was still 2 decades away from realizing the role of ozone in shielding life on Earth. There were only 4 countries that had the know-how to develop an ozone sonde at the time. Ozone sonde helped in collecting data on ozone distribution and its geographical variations. Anna developed an ozone sonde on her own steam that helped place India among the only 5 countries that had the capacity to develop its own ozone sonde independently.
The ozone sonde is a typical example. Britishers were making measurements from all over the world about ozone in 1960s. The world was not very aware about ozone hole, but she in her long sight decided that it is necessary that we measure the ozone content in the ground level and also in the upper levels.
World Meteorological Organization was quick to recognize Anna's foresight and expertise in collecting reliable ozone data. Soon they made her a member of the International Ozone Commission. 1963, India was getting ready for its historical first rocket launch. Vikram Sarabhai requested Anna to set up a meteorological observatory and instrumented tower at Thumba rocket launch facility for regular atmospheric observations. She and her team accomplished this critical task in just 2 days before the launch of India's first rocket. Anna and her team joined the jubilation when India's first rocket thundered into the clear morning skies on November 21st of 1963. 1969, Anna Mani was transferred to Delhi as the Deputy Director General of Instrumentation Division, IMD. She was now the first woman scientist in India to have come to this prestigious position. Anna played a prominent role in the famed Indian Ocean experiment in 1960s. She and her team equipped Krishna and Varun, the Indian Navy ships, with requisite weather measurement instruments. She was elected a member of the Advisory Working Group to Commission for Instruments and Methods of Observations, the Radiation Advisory Group to the World Meteorological Organization, and a member of CIMO working groups on atmospheric electricity and precipitation. Anna served in the working group to the Commission for Special Applications of Meteorology and Climatology and Applications as well. During her stint as Chairman CIMO, she was able to put worldwide radiation measurements on a stable basis. Anna's efforts saw an observatory coming up in Davos, Switzerland, and a World Radiation Data Center in Leningrad, USSR.
There is a physical meteorological observatory in Davos, which was maintaining a good number of instruments, but it was privately held and funded by Swiss government. Suddenly, the politicians in Switzerland, they decided not to fund it properly, so they reduced it, and they were at a stage of closing down the observatory. Miss Mani gave a helping hand. She argued, fought with the World Meteorological Organization, and made the observatory to be recognized as World Radiation Center. That was a big contribution by her.
Anna achieved a remarkable feat as the head of instrumentation department in the year 1957-58. It was International Geophysical Year. There was a growing interest in atmospheric physics in India as in other parts of the world. Government of that time decided to set up a network of stations for solar radiation measurements. Solar radiation is radiant energy emitted by the sun, particularly electromagnetic energy. However, India had to import solar radiation instruments. Miss Mani took up the challenge of designing and manufacturing a whole range of solar radiation instruments all by herself. She could now successfully enable India achieve self-reliance in making sophisticated instruments such as pyrheliometers, pyranometers, and pyrgeometers. By 1970, thanks to Anna, India had as many as 35 radiation stations with instruments that met world standards. Not just that, Pune now came to be recognized as the regional radiation center for the whole of Asia too. The international community of radiation scientists recognized Anna's phenomenal contribution to radiation measurements in the tropics. So they made her chairman of Commission for Instruments and Methods of Observation. Anna helped World Meteorological Organization to designate international and national standards for almost all meteorological parameters.
At that time, we were concentrating upon aeronautical meteorological instruments for safe landing of aircrafts in all the airports in India. Because there are 7 different kinds of meteorological instruments required for safe landing aircrafts in all the airports. Of course, Miss Mani started it. The first project was current weather instrument system, wherein we can measure the pressure of the runway, temperature of the runway, humidity of the runway, wind speed and wind direction of the runway while landing, and visibility, which is very important, height of low cloud prevailing in the runway. Because no pilot is allowed to land unless he sees the runway physically. There is nothing like blind landing system for civil aircrafts. These instruments we were manufacturing here in Pune with our workshop, and we were able to install in Delhi first and Bombay installation of aeronautical meteorological instruments for safe landing of aircraft.
1976, Miss Anna Mani retired as Deputy Director General of India Meteorological Department. That marked the beginning of a new phase of Anna's mighty contributions that strengthened India's meteorological capacities. She returned to Raman Research Institute, Bangalore as visiting professor. Anna prepared 2 volumes of books on solar radiation on the request of the Department of Science and Technology during this time. The book, entitled Handbook of Solar Radiation Data for India, came out in 1980, and the one entitled Solar Radiation over India saw light in 1981. Anna was keen on putting India on a strong footing in tapping the tremendous potential that solar and wind energy offered. She worked on several projects intended to harness wind energy for India in her post-IMD days. She went ahead and set up a laboratory and workshop to this end in Bangalore. She believed that India would not be able to make progress in tapping solar and wind energy without accurate, extensive and reliable knowledge of solar fluxes and wind patterns in different regions across India. She energized the country's desire and efforts to harvest non-conventional energy sources. Styled after the lab and workshop she founded during this phase in Bangalore, several others were rolled out across India. Indian National Science Academy awarded her with K.R. Ramanathan Memorial Medal, and International Ozone Commission awarded her with a citation for her contributions spanning over 30 years. 1994. Anna, at the age of 76, suffered a stroke that incapacitated her for the rest of her life. The dynamic lady of action who enabled India stand on her feet in weather instrumentation was now confined to a wheelchair for the rest of her life. A visionary who worked tirelessly to enable India achieve self-reliance in weather instrumentation was now dependent on her sister and family that lived in Trivandrum, Kerala. Miss Anna Mani laid a solid foundation for India in weather instruments that are employed for measuring and understanding weather systems. These instruments gather vital data from different layers of Earth's atmosphere and different geographical locations. The data thus gathered makes weather forecasts possible. Today, people across the entire socio-economic spectrum enjoy the benefits of weather forecasts. They help them take life-saving decisions, time-saving decisions, and money-saving decisions. From Navy, Air Force, and Army to aviation, to marine transportation, to farmers, to fishermen, to businesses across the industrial spectrum, the whole nation of over 120 billion people in India directly or indirectly benefit from up-to-the-minute weather forecasts. And they come from India Meteorological Department. How do they do it? With the help of weather instruments that are designed and manufactured at its Self-Reliant Instruments Division in Pune. Miss Anna Mani can well be described as the mother of India's weather instruments. She represents a generation of many others of her ilk that strived hard to turn Make in India a reality. It is not hard to see how Miss Anna Mani continues to touch the lives of each one of us, not only in India, but almost in all nations around the world. She continues to live in the hearts of people who knew her and worked with her. She continues to inspire us to be more and do more. As a socially committed scientist, leader, patriot, administrator, humanitarian, and a wonderful human being, she made a difference to millions of lives with her dynamic life alone, single-handed.